Hi everyone, welcome back to our channel. Today we are going to do an experiment on measurement of energy using an energy meter, and we are going to calculate the error created by this energy meter. Okay, so now let us try to see the circuit diagram. The circuit diagram for the calibration of energy meter is this one. So here you are going to have just an auto transformer. This is the auto transformer we require, and we require an energy meter, and we require a voltmeter, ammeter and LPF wattmeter and two 60 watts bulb. Okay. Now coming to the circuit diagram, here based on this circuit diagram I am going to give the connections. So just voltmeter will be connected in parallel, continued with an ammeter in series, continued with an wattmeter, continued with an load. Okay. So ammeter, wattmeter and load will be connected in series, and voltmeter will be connected in parallel. Okay. Now let us try to give the connection. You can see here from the supply it is connected to the input of the auto transformer. Now from the output of the auto transformer, this is the output of the auto transformer, we are going to connect to the energy meter input. Okay, with positive is nothing but a phase, and from the neutral of the supply we are going to connect to the energy meter. So this is our energy meter, old disk type. So this is going to measure the kilowatt hour, is nothing but how many number of units consumed by this meter. Okay, now after connecting the input, let's try to give the output connection. So pre-there, first the voltmeter will give it later. First we'll try to give the ammeter connection. So from the phase connect to the M and output of the M. So output of the ammeter. So you can see here, I will make it in vertical position, then you can understand better. So this is the input of the ammeter, and output of the ammeter we have to connect at M, and M and C has to be short circuited with an small wire. Okay. So this is nothing but the short circuit wire. We are going to short circuit M as well as C. So now MC is short circuited. Okay. And now so from L it has to go to the load. Okay. So this is the terminal L. So from load we have to connect to the one end of the lamp. Okay. And so now you can see here the red color wire are used to show that this is the flow of current. Okay. And the return path I am going to show with an black color wire. So from the lamp you can see here, from the circuit diagram, from the lamp it goes to the neutral. So from the lamp it directly goes to the neutral, and one more connection from wattmeter also it goes to the neutral. Okay. So that wattmeter connection also I am indicating with an black color wire. The rating of the wattmeter is 300 volts. Connect 300 here and connect an neutral here. Okay. So with this part the ammeter connection as well as the wattmeter connection is completed. So here we are connected only one 60 watt bulb. Now let's try to connect another 60 watt bulb in parallel. Okay. So connect phase to phase and connect neutral to neutral. Okay. So this is how to connect phase to phase as well as the neutral. Okay. So now let's try to give the remaining connections. Now the last one we have to connect the voltmeter. Okay. So to connect the voltmeter we are going to have the two wires. So connect the negative to the negative and positive to the positive. Okay. So this is the phase and connect it to the positive. Now this experiment will help us to calibrate the energy consumed by the watt hour and the error developed by this wattmeter. Okay. Now we'll try to proceed with the experiment in the upcoming. Hi everyone, welcome back to our channel. Today we are going to do the experiment on calibration of single phase energy meter and the error created by the and single phase energy meter. Now already the connections we had explained in the previous video. Now we'll try to do the experimentation, the process. Okay. So first we have to keep the auto transformer in minimum output position and all the connections are set up. Okay. So now gradually we have to adjust the voltage. Okay. So you can see here this voltage has two scales, one is 150 scale and 300 scale. I had connected to 300, that's why it is multiplied with 2 times. It is directly connected with upper scale only 1 ampere, that's why into 1. When coming to the ammeter, it is having approximately only 2 amperes and 300 volts we have been connected, so it is going to get the factor. Okay, so maximum we can take 1 ampere or 2 ampere. Still ammeter is of 1 ampere, I am considering only 1 ampere, and voltage is of 300. The multiplication factor is into 2. Okay, now let us try to do the experiment. Okay, the process of doing the experiment is so we have to apply the voltage using an auto transformer. Okay, so let us try to do with 40 or 80 volts. Okay, so you can see here I had connected two loads. The experiment will be done as fast as possible. Why? Because the load is heavier. Okay, now I am applying slowly. I am applying an voltage of you can see here, as soon as I gradually apply the voltage, the current starts increasing and the power is consumed by the load. Okay, so now we can see here I am applying the voltage. Okay, so here I am considering I have been applied 30 volts. Okay, but it is not 30 into 2, and this is the current drawn, and this is the power consumed by the wattmeter, and you can see here the bulbs are glowing. Now we want to tabulate all these readings. So coming to the tabulation, first one we have to write down the voltage, and we have to write down the current drawn by the ammeter and the power, and we have to tabulate this, and we have to calculate the error using these two factors. So the process of doing here is, now let us try to check out with 100 volts. Okay, so now gradually I am increasing the voltage. As soon as I increase the voltage, you can see that the bulb will start glowing. Okay, so now I have been gone up to an voltage of 100 volts. Okay, so 100 by 2 is 50, that's why I applied a 50. 50 into 2 is 100 volts, and this is drawing a current of 0.41, 0.42, 0.43. So let's try to tabulate the readings. First one, voltage is 100 and current is 0. So voltage I had applied is 100, and the current drawn by the equipment is 0.45, and power, coming to the power, here you can see here it is drawing approximately 22 into 2, so which is nothing but 22 into 2. So now we want to take the time taken by the energy meter. So in order to do this energy meter, let us try to see here. So it has to take how many revolutions is very important. Okay, so now for 2 revolutions you should do the time taken by the watch. Okay, so now let us try to see here. You have the stopwatch like this, and let's try to measure the time taken to make 2 revolutions. Okay, now let us try to watch our energy meter. Slowly it is rotating, which indicates that it is consuming the power. Okay, now at one point we will start taking the time. You can see here the disk has been approached. So now we have to turn on the stopwatch. So I have turned on the stopwatch, and it will try to make 2 revolutions. Okay, so for every 2 revolution you have to take the time. You can see the timer has been turned on and the timer is working now. Okay, so now, so coming to the calculation, let us try to 130 seconds. Okay, so it is going to take a time of 130 seconds. So the seconds we have to convert into hours. So 130 seconds into 1 by 360, if you do it, automatically it is converted into watt hour. So we got from voltmeter, ammeter, the watt hour, and from the wattmeter we got the watt hour, and from the revolutions it has made we had calculated the watt hour. So we will try to compare. So now we want to do the error calculation from meter and from the wattmeter. So first watt hour is the calculation from our meter. If the meters are working well, it will give an watt hour calculation, and already we calculated the number of turns multiplied with by 1200 you will get converted into kilowatt. Then you have to find the error. Okay, so the error formula is E minus ER divided by ER into 100. This is capital letter E, this is capital letter ER. So when you do it, 1.18 minus 1.16 divided by 1.16, then you are going to get approximately some 20% of error. So this error we have to reduce. So this is the process of doing. So it is taking more time. Why? Because the applied voltage is just only 100 volts. Now let us try to do with approximately some 120 volts. Then you can see here our wattmeter will start rotating faster. Okay, so now I am going to apply gradually around 60 volts. So 60 means 120. Okay, so 120 volts have been applied. Okay, so 120 volts, and current drawn by the equipment is 0.5 ampere, and you can see here the wattmeter is already consuming 28 watts. Okay, so 28 watts into 2. Okay, you have to write down the readings. Okay, so write down the readings. Voltage is 120 and current is 0.5 and the power drawn by the equipment is 28 into 2 and the time. Okay, so time taken by the 2 revolutions we have to write down, then automatically you are going to get the watt hour calculation. Okay, and so the number of revolutions we are going to get here, and from number of revolutions divided by 1200 you are going to get the error. If you do the error, you should get less than 10%, then I can say that we had successfully calibrated the energy meter. Okay, so this is the process of doing the experiment and calibrating whether this energy meter is working well or what is the type of error created by this energy meter. So this is all about how you calibrate the whether this energy meter is working well or not with the cross checking with the watt meter. So this is all about the calibration of energy meter. So the calculations also will upload in the upcoming video. So thank you for watching. We'll meet in the another video.